Okay, I guess we should start. Good thing you came early because, you know, it's difficult to get a good seat in here. Thanks for taking the time on this last day. This is a repeat session from what we presented on Tuesday. My name is Wolf Kaiser. Here's Uma. She's going to tee us off with ArcGIS Pro for .NET, beginning Pro customization, extensibility. So this is kind of an intro to the ArcGIS Pro SDK. Kind of teaches you some of the things you need to know how to get started, what the capabilities are, and then we dive into some of the programming patterns that are specific to the ArcGIS Pro SDK. So, Uma?
Okay, so good morning and welcome to the ArcGIS Pro SDK for .NET, beginning Pro customization extensibility session. I'm Uma Harano and here next to me is Wolf. So let's get started. Here is a session overview. I'm going to start with the two extensibility patterns supported by the Pro SDK, the ArcGIS Pro module add-ins and the managed configurations. And then Wolf is going to take over and he's going to talk about the asynchronous programming concepts. And then he's going to give you an overview of the MVVM. That's the model view model. And then he's going to finish up with showing you how you can use existing Pro functionality in your own add-in development. The ArcGIS Pro SDK for .NET extends the Pro application using the .NET framework. There are two extensibility patterns that are adopted for this, the Pro module add-ins and the managed configurations. The SDK offers a collection of project and item templates. You can download it from directly within Visual Studio Marketplace, and we currently support versions 2015 and 2017. An important thing I want to mention here is that the ArcGIS Pro API comes with Pro out of the box. The Pro assemblies are all file-based references and nothing gets registered in your global assembly cache. Here is a little more information about the features and patterns of the SDK. It's built for the 64-bit platform. The UI is designed using WPF, which is the Windows Presentation Foundation offered by Microsoft. We use an MVVM pattern, which is the model view model. And since Pro is a multi-threaded application, when you extend it with the Pro SDK, you have to work with multiple threads. And you use an asynchronous programming pattern for this. And Wolf will be covering this in the second half of the session. So the ArcGIS Pro add-in is one of the extensibility patterns. You use an add-in when you want to modify the existing features and functionality of Pro to suit your custom workflow. So all the Pro UI elements, such as your buttons, your dock panes, etc., they're all extensibility points within an add-in. And the SDK offers item templates for pretty much all these UI elements. Here on this slide, you can see a Pro UI, the sort of customizations that you can do with an add-in. And when you compile an Addin project in Visual Studio, you get a compressed Esri Addinx archive file. This gets installed in your C user's username location. The full path is given here at the bottom of the slide. So this location is one of the well-known locations from which Pro will load your add-ins from. We will see this in the demo coming up. So when you work with an add-in, you start with two basic things, the config.daml and the module class file. An add-in uses a declarative framework to define its UI elements. And the config.daml file in your add-in is where you define these UI elements. We will see more of that in the next slide. The module class file in an add-in is the hub and central access point for your subsystem. So if you want to modify any functionality within a subsystem, you start with its module. It's very similar to the extension object used in the ArcObjects 10x framework, and it's a singleton instantiated automatically by the framework. Here is some more information about the config.daml file. This is the file where you define your UI elements in your add-in. And on this slide, you can see a code snippet of a typical config.daml file. Notice how you use simple XML syntax to define the UI elements. Your add-in, for example, you could be creating a doc pane, perhaps add a new tab on the Pro ribbon with a group that hosts a collection of buttons and galleries, etc. All these UI elements get defined in the DAML. An important thing I want to mention here is that the DAML is used to make additions, modifications, and deletions to the Pro UI. Okay, here in this demo, I want to show you how you can use the SDK to make an add-in project. I have Visual Studio open here. The SDK is already installed, and I'm going to create a new project. File, New Project. The ArcGIS folder is expanded here. I'm going to select the ArcGIS Pro add-in folder, and you're presented with your two project templates for your two extensibility patterns, the add-in and the configuration. I'm going to select the add-in. I'm going to accept all the defaults for the location where I'm going to save the project and click OK. So Visual Studio stubs out a project template for me. This is my add-in project. So this is how the Solution Explorer looks. Here within the references, notice that the references to Pro assemblies are already stubbed out for you. These are assemblies that you find in the Pro installation location in your bin extensions subfolder. Here in the Solution Explorer, notice the config.daml and the module class file that we saw in this slide. The file open here is the config.daml. This is where you define your UI elements. Here within the add-in info element, you add your metadata information, any descriptive information regarding your add-in. Notice the ID attribute. It is set to a GUID. This uniquely identifies your add-in, this one right here. Here within the insert module element, you can see all the tabs, groups, and controls that are stubbed out for us. This is where you would add your buttons and dock panes and other UI elements. An important thing I want to show you here is there's a class name attribute. It's set to our module's class name. Here in this case, it's set to module 1, and you can see that it matches our class file, module1.cs in the Solution Explorer. Here is the appears on add-in tab attribute. This is a quick and easy way by which you can get your UI controls onto the Pros ribbon without creating new tabs. So I'll show you that in the demo also. So at this point, to this project, I'm going to add one of the Pro SDK item templates. So to do that, I select the project in the Solution Explorer, right-click to access the context menu, add new item. And here within the same ArcGIS folder, I'm going to select ArcGIS Pro add-ins. And these are all the item templates that are available for you. You have your buttons, dock panes, a gallery, etc. These are all pretty much all the UI elements you can add to Pro. And for this demo, I'm going to pick a button. I'm going to call this button Addin Demo button. And here is my Addin Demo button class file. You can see that it inherits from the frameworks button base class. And the onClick method is already stubbed out for us. This is where you would add your custom functionality. So for the purpose of this demo, I'm just going to show a message box with a simple message and a caption. I'm going to fix the references here. I want this to have the Pro look and feel, so I'm going to fix the reference to use the desktop framework reference. And then within the config.daml file, notice how the SDK has inserted our new button element within the controls group right here. So the class name attribute here points to our Addin Demo button class file. And here you have the opportunity to set the caption, tooltip, etc. And this button by default gets hosted into this group right here using its ref ID attribute. So I'm going to build this. Notice this Addin folder defined over here. This is the GUID that we just saw in the config.demo. This matches that ID attribute that I showed you. And once you go into this folder, you can see our Esri Addinx file. This was created by the Visual Studio compiler, and this is our Addin. And this folder right here is one of the well-known folders from which Pro will load the Addin. So let's see that. So from within Visual Studio, I'm going to start the debugger. This will launch ArcGIS Pro, which will load our Addin from that folder that I just showed you. Just going to open a project. And here is our Addin tab. So by default, our button should appear in this convenient Addin tab, and there is our button. So when I click on this, our message box is displayed, but you could add your own custom functionality instead. So that was a quick demo to show you how you can use the SDK templates to create a Addin project. Now let's go back to our slides. Okay, moving on to managed configuration. This is another extensibility pattern, and it is very similar to an add-in, but it offers more ways by which you can extend the Pro application. It helps you design a version of ArcGIS Pro that reflects your organization's brand and workflow. So it has all the functionality of an add-in, plus the ability to modify ArcGIS Pro's startup experience by changing things like your title, your icon, splash screen, about page, and the start page. It also allows you to conditionally change your UI at runtime. So here on this slide, on the left, you can see that ArcGIS Pro's default start page. This is something that you're familiar with. And here on the right, you can see the custom start page. So this is the kind of start page customization you can create with a managed configuration. And when you compile a managed configuration project in Visual Studio, you get a Pro config.x file. It's another archive file with the same xcopy and double-click deployment like an add-in, and it gets installed in your C users public folder. So instead of a user specific folder, that's where it gets installed. So to run a managed configuration, you call the configuration name on the command line by passing it to the /config argument. So you can see an example here on the slide where the Acme configuration is passed on the command line, right here. Multiple configurations can be installed on a machine, but you can run only one configuration per instance of Pro. So an important class here is your configuration manager class. It's defined in DAML, and it has a series of callbacks, and you can override each of these to change that particular aspect in Pro, such as your splash screen, start page, about page, etc. So these callbacks are all optional. So if you don't want to change that particular aspect of Pro startup experience, you just delete your callback or you return null. So here now in this demo, I'm going to show you how you can use an SDK template to create a managed configuration project, and then we'll customize that template to suit a custom workflow. So here in Visual Studio, I have a managed configuration project. I've already used the template and created this project. I've made no changes to it. So in the Solution Explorer, you can see the config.daml and the module class file, again, very similar to an add-in. And here is the UI folder, and you see a series of user controls here. One for the about page, splash screen, and the start page. And these are used to override Pro's startup. And the file open here is the config.daml. Here is the configuration element, and within that you have the configuration manager child element. It has a class name attribute that is set to the code behind file that implements our configuration manager class. So let's look at that configuration manager class file over here. So the first thing here is how you, the application name property override. You would use this to replace Pro's application name with your own custom application name. Similarly, you would use the icon property override to replace Pro's icon with your icon. Here within the onShowStartPage callback, a start page user control gets returned to the Pros framework. So the start page user control, it's a view and view model pair, so we implement MVVM. And an important thing I want to mention here is that if you override Pro start page with your own custom page, it's your responsibility to initialize a Pro session with a new project or an existing project. And then here is the splash screen callback, on show splash screen. Very similar, you return a splash screen callback to the Pro framework. And here is the on show about page callback. An about page user control gets returned to the framework, and this gets injected into your Pro's Backstage About tab. So you can write your copyright information here in the Backstage. So at this point, you can go ahead and add any of your SDK item templates, your UI customization, like buttons, dock panes, anything to suit your workflow. So now I'm going to build this solution and run the configuration from the debugger. So notice our custom splash screen. And here is our new start page. Notice that the application name and icon are customized by our project. And I'm presented with a collection of existing projects. I can select any of these to initialize a new Pro session. Notice that the application name and icon is carried over here also. And then I can select this project tab to access Pro's Backstage and select the About tab, and notice this text, Pro Configuration 1. This is our custom About page customization. So this is where you can add your own customization, copyright information. Okay, so now let's customize this template. We will, just for the purpose of this demo, we will assume that we work for a fictitious company that has a geocode workflow. All our users have a series of addresses or parcel IDs that they geocode, and we're going to customize the Pro startup experience to reflect this organization's workflow. So let's do that. So I have a project here in Visual Studio. This is a configuration project, but I already have added my custom UI to this. So here within the geocode folder, I have a reusable geocode user control. It's very simple. It has a text box where you add your address and a find location button that geocodes this address. And the code behind file for this control has the code that launches a Pro session, opens the map view, and zooms to that geocoded location. And then I have my new Pro startup page, my geocode start page. I want to replace Pro's start page with this. You can see that it hosts my reusable control over here. And it has a view model that has public properties that are data bindings for these UI elements. So I want to use this start page. So I'm going to go into my configuration manager class file, then access the onShow start page callback. So instead of using this start page view model, I'm going to use my new geocode start page view model. I'm going to change this member variable also to use the same. And I need to return my new geocode start page user control. So that is all the customization I had to do to my configuration manager template to use my own start page. I'm going to go ahead and use the same splash screen that the template provides. But for the About page, I want to insert my own company copyright information. So I'm going to use the geocode About Page user control. Okay. So at this point, to represent this organization's custom workflow, I want to add another SDK item. So I'm going to access the item templates, and I'm going to select a button item. So this represents your custom workflow. I'm going to call this my custom button. And then by default, this button will appear on the Addin tab, but I want to change that. So I'm going to delete this appears on Addin tab attribute. And instead, I'm going to uncomment this piece of DAML over here. This is stubbed out by the SDK. And I'm going to add this new button to a geocode tab on the pros ribbon. Okay. So now I'm going to build this solution and run the configuration from the debugger. You can see my splash screen. And here's my start page with the geocode user control. It's pre-populated with an address. I'm going to use this address and click Find Location. So a pros session is initiated. A map view opens up and it zooms to that address. So here is my new custom geocode tab with my button, representative of my custom workflow. And inside this project tab, on the About page, you can see my custom copyright information. Okay, so now here, this is Pros Backstage. Notice the new and open tabs. This doesn't really go with our organization's geocode paradigm. We want our users to initialize Pro by geocoding an address. So I want to delete this new and open tabs, and I want to insert my own custom tab. So let's make that change. So the SDK templates, they provide us with an item template called Backstage Tab. So I've already used the template and added a new Backstage tab to this project. It's there in this folder here. So the SDK item template has stubbed out a user control and a view model pair. So within the user control, I have hosted the same geocode user control that we saw in the start page. It's the exact same thing. I've just hosted it here in this new Backstage tab. And it has a view model associated with it that has public properties as data bindings. And within here in the config.daml, the SDK has stubbed out these lines of DAML here. I'm going to comment that. And within the Backstage element, notice the insert tab element. So this is again stubbed out by the SDK. It has a caption set to geocode because I want my new tab to say geocode. The class name attribute is set to my new Backstage tab view model. And here is the content child element. Class name is set to the Backstage tab's user control, to the view. And remember, we talked in the slide of how you can use the DAML to make additions, modifications, and deletions to the Pro UI. That's what I'm doing here with these two lines. I'm using the delete tab element. I'm setting the ref ID of this to the Pros new and open Backstage tabs DAML IDs. So that's what. So these two lines are going to delete the Pros new and open project buttons. And another thing I want to mention here with the insert tab, I want my new geocode tab to appear next to the Pros Save Project button. So I used the insert and place with attribute to configure that. So this is again Pros Save Project button DAML ID. Okay, let's see how this looks. I'm going to build this solution. I'm going to run the configuration. So this is the same start page that we just saw. I'm going to use the same address and initialize a Pro session. So after the project opens, let's access the Backstage. I'm going to select the project tab. And notice how my new and open button are now gone. They're replaced by a geocode tab. And it has the exact same user control that you've seen. In this case, it's populated with a different address. So I'm going to geocode that address and initialize a new Pro session from the Backstage. So that was a demo to show you how you can use the Configuration Manager template to customize a Pro startup experience to reflect your organization's workflow. So back to the slides, and Wolf is going to show you some concepts about asynchronous programming.
All right, thanks, Uma. So as Uma explained the extensibility patterns of Pro, I'm going to talk a little bit in regards to the programming patterns. So these are the things that are a little bit different from, if you're new to ArcGIS Pro, different from the ArcObjects platform, if you're familiar with that. And first of all, we're going to talk about asynchronous programming, something that really wasn't available out of box with ArcGIS Pro. ArcGIS Pro is a multi-threaded 64-bit application. And the main motivation to use asynchronous programming is to keep the user interface responsive. So on the right, you see a little screenshot of the dreaded ArcMap not responding screen. This is our motivation for asynchronous programming. So an important asynchronous programming pattern for the SDK, first of all, we have the use of the async and await functionality in C# and VB.NET. And I'm going to talk to that in a little bit detail coming up. And then using the ArcGIS Pro Framework's QueuedTask class, which is utilizing the ArcGIS Pro multi-threading scheduler. So we're going to talk about that in the coming up slides. In regards to the internal threading model in ArcGIS Pro multi-threading incorporates the latest asynchronous language features from Microsoft. So this is not custom implementation, this is just using what's available from Microsoft. It implements a threading infrastructure that is tailored to reduce complexity. So ArcGIS Pro SDK developers only need to worry about two threads. The GUI thread, the graphical user interface thread, and then a single specialized worker thread that we refer to as the main SIM thread, or MCT. You see that term a lot being used in documentation. SIM is short for Cartographic Information Model. You probably heard that before too. So internally, ArcGIS Pro uses a large number of threads for rasterization, rendering, data loading, geoprocessing, but this all is isolated from the API and from the developer. So as a result, this simplifies the coding and ensures the consistency of the ArcGIS Pro state. So in regards to asynchronous programming, you need to understand that Pro utilizes two categories of methods in the API. First of all, we talk about coarse-grained asynchronous methods. These can be called from any thread, and we're going to go in detail on that shortly. And then we have the fine-grained synchronous methods, and these must be called from within the QueuedTask class. So let's take a quick look in detail into the coarse-grained methods. As I said before, coarse-grained methods can be called from any thread. However, typically these will be invoked from the user interface thread. Coarse-grained methods execute in the background on Pro internal threads. And they use the async await semantic. I'm going to explain that shortly. And coarse-grained methods use the async naming convention, meaning that method names all end with the word async. So on the bottom of this slide, you see a little sample snippet. This is a very simple workflow. And as you can see, these are two asynchronous methods that I'm deploying here. These are coarse-grained functions. So you can see in the naming conventions, you can see the name ends with the word async. So that's an indicator for us that this is asynchronous executed. And you also see the await keyword was deployed here. Now, async and await means that your process, your function that you call is executed in the background. So for the caller, that means that if you call the execute tool async function here that performs my parcel selection, the method will return to you immediately, and the actual functionality will be executed in the background on an asynchronous thread. So if you deploy the await keyword, what you're telling the compiler is, make it so that you don't return to me until all the functionality within that method is completed. So for my specific workflow here, for my business process, this is very important because as you can see, my first line performs a selection, and then my next line actually expects that the selection has been completed because I am zooming to my selected object. So if there's no selection, then the zoom won't work because my selection is not complete. Hence, I actually use the await keyword here to make my business logic sequential. And that leads me to the first demo here for the coarse-grained methodology. So what I did here is I wrote a very simple add-in, as Uma showed you before. And then in the onClick method to demonstrate this functionality, I call one method called coarse-grained methods. And as you can see, the content of this coarse-grained method is pretty much identical to the slide from before. I perform first a selection, so I create a new selection specifically to this where clause. So I select a county that's with the name of Zurich. And once the selection is performed, I then zoom to that selected set. And as you can see, I did not use the await keyword here. So very likely, when I run this sample, my functionality will not work as expected because it will be executed in the background. When everything is done, I'm going to show this message box here. Show grain methods is done. So let's build this, and then we're going to run it, and we're going to see what it does. My expected workflow would be that the feature is selected, and then the map zooms to the selected feature. But as I just mentioned, very likely I'm not going to get that result because of the asynchronous behavior. So I'm going to wait till the map is loaded. Okay, then I'm going to select my asynchronous course tab, and I'm going to click my button here to execute my function. So as soon as I click this, you can see immediately this message box popped up. And okay, we kind of got lucky, but you see it's zooming now. So that means that the selection was actually performed by the time the zoom to happened, but you see the message box actually popped up before the zoom was completed. So this is not the kind of workflow I want. I want my workflow to be sequential as I read it in my code. So let's close this. And by the way, this zoom that you just seen, this doesn't always zoom. So many of my demos, it will actually not even zoom because the asynchronous call to the selection tool returns immediately. The zoom is executed immediately and put on a background thread, and neither one of these functions will work. So it's a little bit random behavior you're getting here because you're talking about background tasks. So now I want to make sure that this happens properly, and I want to await for the functionality to finish. So I'm using the await keyword in both. So I'm using the await keyword to perform my selection, and then the await keyword to perform my zoom. Now you can see the compiler complains. It did underline my await keyword, and it complains because it says the await operator can only be used within the async method. Well, as soon as I use await, my method actually has to be an asynchronous method because now it will be executing in the background. So I can use the compiler assist here, and I say just make the fix for me. I'm going to click on make the method async. And now you can see the compiler actually fixed the the method declaration for me. My method is now an asynchronous method. The declaration changed. And also the naming convention we talked about before has been fixed by the compiler as well. So now I can just rebuild and run this again. And now when I rerun this, I expect my business logic to execute sequentially, and the message box only pop up once the zoom to my selected set is complete. So let's try this out. Wait till my project loads. Okay, click on my asynchronous tab. Now, also, because my method is now an asynchronous method, my user interface should still be responsive. So what I'm going to do as I click on this functionality and execute my business logic in the background, I'm going to go up here and click on the tab to make sure that my user interface is still responsive. So I'm going to click on the button now, and then quickly I'm going to click on one of these guys, and you can see the Insert tab came up, now the Analysis tab came up, while the system is performing my business logic. And this time you see the dialog only popped up when my business logic was completed and my map had actually zoomed to the selected set as I wanted. So this kind of demonstrated the use of coarse-grained functionality. We just programmed something asynchronously, and you can see it's not that difficult to understand. Now, let's go into fine-grained and synchronous methods. So these methods must be called using the QueuedTask class. There's a much greater number of fine-grained methods and classes. Also, because these methods are synchronous methods, there is no async and await use of the keywords. They run on the MCT, the main sim thread, and they are actually designed so you can create your own coarse-grained asynchronous methods. In other words, this allows you to write your business logic as a background task. Below, you kind of see what this will look like when it, very simple business logic written as a background task. In this code snippet, I actually find my parcel layers. I then specifically look at my first parcel layer that I find, and I perform a query filter given a specific where clause, and then finally perform a selection using that query filter on my feature layer. So you can see this is performed within the QueuedTask run, but we'll see that in more detail on the next slide. So QueuedTask uses the Pro Framework's custom task scheduler. And it's used to run asynchronous synchronous ArcGIS Pro SDK methods in the background. So all synchronous API methods are listed in the API reference guide using the following text in the description. And we'll see that in the upcoming sample. It always will say, this method must be called on the MCT, use QueuedTask.run. And examples of synchronous methods in Pro, get spatial reference, query extend, and virtually all geometry operations. So you can imagine when you write your business logic, you have to deploy this programming pattern. The usage is, as you can see down here, task T equal to, and then QueuedTask.run. And in this case, I specify what's referred to as a lambda expression, which in other words allows me to inline specify my method so it becomes much more readable. And you'll see that in the upcoming samples, which we get to right now. So let's look at a fine-grained sample. And what I did here is, again, I programmed a very simple add-in. It only has one button, And in the onClick, I call two methods. I call my Finegrained methods async. So let's take a look at this method first. So this is pretty much a copy of the snippet you just saw on the previous slide. I perform a business functionality in here by, again, looking at a feature layer. I then specify a query filter, which is an attribute filter. And then I perform a selection on that feature layer. So in this case, it's my parcels feature layer. And if I hover over this select method, I get the IntelliSense documentation, the description of the method. And this font is maybe a little bit small, but you can see that the description ends with, this method must be called on the MCT, use QueuedTask.run. If I don't run this method within QueuedTask.run, then I would actually get an exception thrown. And the same thing happens to my zoom to selected. You can see this is not the asynchronous counterpart I'm using here. I'm using the synchronous version. It doesn't have the async name on it. But also if I hover over it, you can see this method must be called on the MCT, use QueuedTask.run. So what I do in my business logic here, I actually I program my business logic. Now imagine this would be geometry operations, buffer overlays, whatever your business logic is, and you surround this whole business logic piece inline. Again, here's the lambda expression that allows me to specify the code within my little function. And you execute this within the QueuedTask class, and specifically you use the run method. So a very common pattern. Now let's go back to the onClick method. And so very often when you write your own background functionality, you want to return a parameter from that. So you have some kind of a result and you want to return it. So you can see in this case, I want to return a count parameter. Specifically, this is a selection count. And if I look at this method, then you can see it's actually the very same business logic I used before, but at the very end, I want to return the count of my selected records, which will be only one in this case. And the way I do this, the run method is a templated method, so I can actually specify what return parameter I want to return from my run method. In this case, I just want to return an int. So I specified int, and I return an int. But you could return anything, a feature class, your own design class, whatever. So what your business logic provides. So let me build this, and then I'm going to run this. And what I expect is my first Finegrained method runs within the QueuedTask background task scheduler, and it will execute in the background. However, I await this method to be finished. It will zoom to a location, and then I select yet another record. I zoom to another location, and this time I return the count. Then I expect my method to display that count, and finally I say my onClick is done. So let's run this and see whether my business logic works as expected. And again, I have now written business logic with synchronous methods that will execute in the background. So if I click on my user interface while it's performing my business logic in the background, it should still be responsive. So we're going to try this again. So I'm going to click here, and then maybe I click this imagery, and I click this guy here. So as you can see, as it was doing this, my business logic, I was able to still use the ribbon. So imagine you have longer execution times in your business logic, then this might be very handy to do. So it now finished. You can see it returned my selection count, the result of my business logic to me. I display it, and once that's done, the onClick is done. So Again, I executed background tasks in a very specified sequence that I needed for my workflow by the use of using the await syntax and then writing my own synchronous methods within the context of QueuedTask. So another programming pattern is the MVVM pattern in add-ins. So MVVM stands for Model View View Model, and MVVM invariants are the de facto pattern for WPF UI implementations. This means that MVVM is not something specific to ArcGIS Pro SDK. It's something that's actually deployed in Microsoft WPF applications. ArcGIS Pro MVVM is built on top of ActiPro. In case you want to learn more about that, then you can use the link we provided on the slide. And the basic pattern is the view model is declared in our DAML and then implemented in code. We'll see that shortly. The view itself is referenced in DAML and is implemented as a WPF, a user presentation framework user control. And the model itself is optional. So to customize the Pro UI, you have to use the MVVM framework. You cannot use any substitutes. So for a few examples that deploy the MVVM pattern in Pro, we're looking at some framework elements here, the doc pane, the pane, custom control, embeddable control, and property page. So these are just some of the samples that deploy MVVM. So again, the model in MVVM represents the classes that represent the data that's consumed by the application. The view is actually the user interface elements the user interacts with, and that's defined in XAML. And then the view model are the classes that wrap the data coming from the model and provide the business logic for the UI for the views. And we'll see that in the next sample, how this works. And when you implement your Addin UI, you just implement the user control in WPF and .NET. So that allows you to just use any sample that's available on the internet. And there's plenty of them, and you just can copy and paste any kind of WPF MVVM snippet into your UI or into your code. I've done that plenty of times. So the differences in MVVM for add-ins versus standard WPF applications is you've got to consider the multi-threading in add-ins, and then also the ArcGIS Pro styling, and we're going to see that in the sample. Here's the next demo coming up. So first of all, I'm going to show you how to create one of the MVVM controls from scratch. I have opened up Visual Studio, and I'm going to create a new project within Visual Studio. And as Uma showed earlier, I'm going to drill down to a module add-in. I click OK. I just accept all the defaults. So this will create my add-in with no user interface components in it. To add the user interface components, I click on Add and then Add New Item. And again, I drill down to my ArcGIS Pro add-ins. And now I want to add a doc pane to this, because in the next demos, I'm going to work with the doc pane. So I click on doc pane and add. And now the item template actually stubs out all the code and all the settings, everything I need to use my doc pane for me. So if I look at the config.daml, I can see that at the it added a button to me. The button has been added so I can initially show my doc pane. And then it also added the doc pane under the doc panes tag. And you can see this one has actually two components. It has the doc pane itself, and it points to a class name called docpane1 view model. This is my code behind business logic that it points to. And then the content itself, which is the user interface, it points to docpane1 view, which is the XAML user interface, my user control, that is used to define my UI. So if we look at the solution here, we can see that my item template actually created everything for me. So if I double click on my doc pane 1 XAML, which is my user interface, you can see there is a very simple blank doc pane created. All that it has is when I look at it closely, there's a text block. And when I look closely at the text block, there is a text binding in here. This is something that's called data binding. One of the patterns you need to understand when you work with MVVM. It allows your view, your user interface, to be decoupled from the code behind. So the way this works is I can, my user interface expects a property called heading that contains my text that is then displayed in the user interface. So now let's go to the code behind that stopped out. So when we look at the code behind, you can see that our item template stopped out a show method for me. So I can call the show method to display my doc pane if it's not visible. But also we were just talking about the heading that's displayed in the UI that's data bound to a property. So here in my code behind, in my view model, I define a string property is heading that displays actually this initial content. So I can call it my test doc pane here. So I change this text here. And this variable is being used by the UI during runtime and displayed. So let's run it. So this is a concept called data binding. And again, that's something that's standard Microsoft WPF. So nothing specific to the Pro SDK. It's something that you can learn from Microsoft on how that works and how that's being used. So if I look at my add-in, and as Uma explained before, by default, if I create a new user interface element, a new add-in, everything is being put into my add-in tab. So if I click on this, you can see the button that was created to show my add-in initially. And now here you can see the doc pane with my customized text that I changed. And because the system uses a doc pane base class, from the API, I get a lot of functionality out of box that I didn't even program. It is inherited from the base class that we are using from the API. So this was just how to create a MVVM control from scratch. Now, let's take a look at Let's take a look at a little bit more sophisticated control. And what I did is the very same control you just seen, I modified slightly. So what I did is when we look at the user interface first, I inserted two items here. I inserted a button on the top. Remember before, you probably remember what that doc pane looked like. It was just like a box. So now I inserted a button. I inserted also a list box. And again, this is done through standard Windows, so I can go to my toolbox here. I can select the GUI element that I want to add, and I can just drag and drop it onto my form to add that GUI element. However, you can see this button doesn't look like a normal Windows button. So when I click at this button, I can see the XAML code that defines this user interface element. So first I can see, this is a button tag. So this is a button. This determines where it's being displayed. But here's my command, and again, it's using data binding. So it expects that there is a iCommand property, a command pattern. An iCommand pattern expects that there's an iCommand property that's defined in my code behind with the name of refresh bookmarks. And what I do here is I want to fill my list that you can see here below with a bunch of bookmarks. And I do this in the code behind, and my UI is linked through data binding to my refresh bookmark code behind. Also, if you notice here, I'm using a style. This is the ArcGIS Pro style, and that makes it looks like an ArcGIS Pro button. If I delete this button, this style, you can see the button look and feel doesn't look like Pro anymore. It now looks like a standard Windows button. So let me undo this. So now it looks like my Pro button again. And then I have a second element here, and in this second element, this is my list box. Again, I deployed data binding. First of all, I want to display a bunch of bookmarks in here that I add with my refresh button. And the item source for the items that I want to display here are data bound to a collection of bookmarks, which I simply call bookmarks. Again, when I look at my view model code behind, there should be a property that's called bookmarks, which is a collection of one or more bookmarks. And then finally, when I click on this, I have an attribute here. It's called selected item. And again, with data binding, I can tie this to a property on my code behind called selected bookmark, which is being set as soon as I click on one of my items. So just to look at the code behind really quick, I'm going to drill down into my view model class. And first we see the buttons that are implemented. Again, and this is out-of-box Microsoft.NET. In order to tie a button to the code behind, I have to implement an iCommand interface. I did this here. I have a method called relay command that implements this iCommand interface, and I can specify my execution functionality as a lambda expression inline right here. So what I do here is I say update all my bookmarks. If we go a little bit further down, we can see we have some properties. First, we have the selected bookmark property. So this is being called as soon as I select one of my bookmarks, and the bookmark is select to the one that I click on. So I set it here, and then I do a little bit logic functionality, and finally I say, well, zoom to the selected bookmark. And here's my list of bookmarks. So let's run this and see whether this works. I'm going to close that doc pane. So here's my tab for my sample. Okay, this is stubborn. So let's click on my tab. So here's my demo pane. So again, when I click on this button here, my code behind would be called. It refreshed the list of my bookmarks that was set in the property in my code behind, and then the list displayed whatever was in my collection of bookmarks. So there's 3 of them in here. 1, 2, 3, I click on them and it will zoom to that location. So MVVM in a shell, very simple. We implemented a list, a button, and some text. So let's close this so I don't get confused. All right, back to the slides. So now finally we talk about using existing ArcGIS Pro elements in your add-in. So there's a lot of functionality in ArcGIS Pro in form of framework elements that you can use in your add-in, including buttons, tools, galleries. So in your config.demo, you would add the existing Pro framework elements by reference using the ArcGIS Pro's unique element ID. So you see on the right side on that screenshot, I created a new tab. I added the bookmarks navigation element there that exists already under the map tab. But I want to use that very same button in my add-in, in my workflow. So I just borrow the functionality from within ArcGIS Pro. And you can see that the demo to make this work is on the bottom here. And the button reference that I'm using here is the Esri mapping bookmarks navigate gallery. And we have plenty of documentation in our document website where you can look up what these different DAML IDs are for the buttons, for the tools, for whatever there exists. So you can utilize that documentation. And there's also a tool that helps you to do this within code. So now I do something that we refer to also as hooking existing Pro commands in code. So I want to use the Pro framework's get plugin wrapper method here. So I can give it any kind of Pro's element ID that I get from my documentation, and it returns to me a iPlugin wrapper interface. And buttons, for example, all implement the iCommand interface. So if you look at the code snippet below, you can see I'm actually looking for my Esri mapping create bookmark button. I call the framework applications get plugin wrapper function. It returns to me the iPlugin wrapper interface. However, I cast it to an iCommand. And if the cast works, then I know this in command. As soon as I know it's an iCommand, I can check if I can execute this method and then actually perform the functionality of this button by calling execute. So I can use the above pattern to use any kind of ArcGIS Pro button functionality in my own code. This will save me writing a lot of code. And here's a few samples how I add a button to the doc pane. Here, for example, the first sample would be the close ArcGIS Pro command. Again, I have to use data binding in the UI declaration to bind the command property to an iCommand in my view model. And then in return, I have to define the iCommand property in my view model. So the next code snippet right here shows you how I define this. So here is my iCommand property with a setter and a getter. And then here would be the code snippet using get plugin wrapper that gives me the iCommand definition for the existing ArcGIS Pro functionality. On the bottom here is a very similar function. However, in this case, I implement my own functionality that we did, for example, with the previous refresh bookmarks button that we already seen. So relay command implements an iCommand and allows me to specify my own implementation of execute and can execute. So here's the final demo. Hooking Pro commands. And what I did here is I added first in the config.daml, as I showed earlier, I add this bookmark navigate gallery button. So again, all I had to do is I add this snippet here to add the existing button to my tab in the ribbon. I added a button where I have my own image defined. This is the button down here. I define my own image. However, in the code behind for this, and we're going to see that in a minute, in the code behind, I want to hook existing functionality and use it. So I define my own image. It looks like functionality that I implemented. However, under the hood, I call ArcGIS Pro functionality. And then let's look at our doc pane. In the doc pane itself, I made some modifications. I added a create bookmark button. So I added two buttons, a create bookmarks button that allows me to create bookmarks from within my doc pane. And again, this would use the data binding to bind to the code behind. And then finally, I have a exit Pro button that I just, again, use the functionality directly from the slide that you've seen earlier. So let's run this real quick, and we have a few breakpoints. And hopefully we'll see, let me make sure the breakpoints are enabled, which they are not. So let me just set a breakpoint in the create bookmark. This is the important one. And let's run it. Actually, I want to set the breakpoint within the function. So this is the same MVVM CMD demo tab. If you're interested in kind of doing some of these exercises yourself, there's plenty of samples we have on our community sample side. So here you can see my customized tab under the ribbon. Again, this functionality, I just added the reference to the existing button. The image, everything is borrowed from that, from ArcGIS Pro. It's the same then bookmark navigation tool under the map tab. And you can see it comes up with this drop down, a lot of functionality. If I would have to implement that myself, that'd be a lot of work. I also have to create bookmark button here where I define my own image. However, in the code behind, I use the plugin wrapper method to return the interface, cast it to iCommand, and then execute it. And I can create a new bookmark here again using all the functionality from within ArcGIS Pro. Finally, let me get to this function here on my tab. So I'm going to refresh my bookmark list. Now, if I utilize the create bookmarks functionality here, I borrowed the existing functionality. However, when I execute this will actually only create my bookmark. It will not refresh my list. So what I did here is if I create this bookmark, and I'm going to call this test, and I click OK. So now ArcGIS Pro functionality created the bookmark for me. However, now I inserted, using the relay command, my own augmentation, my own addition to the functionality of Pro, and I update my list. So if I run this now, you can see that it refreshed my list as well. So I used Pro functionality, added my own little snippet to it, and I now have my own business flow complete. And again, if you think, well, why would you exit ArcGIS Pro, use existing functionality? If I click on this, you know that there's a lot of functionality built into Pro that's in the code that is not easy to rewrite. So here it checks for all the edits, for all the changes, and asks you to save this project or not. So this kind of completes this demo, and it completes the presentation. Yeah, next slide is, I think there's one more show this afternoon you can visit. 1 to 2, Pro Customization and Advanced Pro Customization and Extensibility. And other than that, I think ArcGIS Pro SDK.net is done for this show. So thank you for visiting, and see us on GeoNet, or stop by here afterwards. You can ask us questions if you have any. And enjoy the rest of the show. Thank you.